Hi there, my name is Ursula Flans. I'm a principal architect with SDK Tek. SDK is a boutique data analytics consulting company who helps our clients leverage their data assets to strategically move their data forward. One of the many benefits we bring to our clients is our analytics accelerators. Based on industry best practices, these accelerators help our clients build out their data platform in a more cost-effective, repeatable, and sustainable manner. Today, I will be presenting the MLOps Accelerator. So what is MLOps anyway? MLOps, which is machine learning operations, is derived out of the concept of DevOps, helping to get machine learning models up to a production state readiness and to make sure that they are continuously trained and monitored throughout their life cycle. One of the key objectives is to ensure that we're getting ML models up to production as quickly as possible. We're seeing a lot of our clients investing in machine learning models these days, but we're also seeing a lot of our clients struggle to get those machine learning models into a production state. We see issues with training with performant code, evaluating and registering models, as well as making sure long-term those models are monitored and retrained before the end users actually see problems with them. One of the key problems we also see within machine learning projects is a lack of understanding of what an initial implementation would look like. Most people envision a machine learning project similar to a data analytics project, but it is much different. Most people assume that we would have our data scientists go into prototyping, then we need to move the model into training, and then suddenly we're in operations. However, that simply isn't true. The ML lifecycle is a much more circular or feedback type of lifecycle than a traditional project. We've broken down into 5 key phases: prototyping, training, model management, deployment, and operations. On this slide, we further outline the key activities in each of the phases. You may recognize some of these as something that your data scientists or machine learning teams already do. They may be doing it in a non-standardized or unorganized way, which is preventing you from getting to production. Let's walk through each of these steps and make sure we understand what they are and what common problems we see in each of those phases. In my prototyping phase, I'm identifying key data points that would be useful for prediction. I'm going to break those into initial features such as temperature and derived features such as a cluster of columns that together help make the algorithm learn. A key outcome is my choice of algorithm. I'm going to be running through a lot of algorithms in a highly iterative manner to find the best one. I'm also going to understand my hyperparameter range. Each algorithm intakes certain hyperparameters based on how they run. So what goes wrong in this phase? It gets complicated. There's a lot of algorithms, a lot of features, and a lot of hyperparameters. They're not all going to be useful, but as we move towards choosing an algorithm, we need to start to track and version control what's been developed. Those features need to be reused in the rest of the phases. Other developers will need to review the model, and possibly other developers could reuse the same features I've developed in this model. A key output of the training phase will be a model that's ready for prediction or inference. To get there, I'm going to train the model using a larger data set, running through all the hyperparameters that I identified in the range, recording and tracking all of the experiments until I can choose the best model. Other key aspects of this, because I'm using a much larger data set, is I need my code to be performant at scale, both for training as well as for inference, so I'll be setting those pipelines up now. A common problem we see in this phase is not preparing for scale or inference. The features we've created in the prototyping phase will often be done in a language that's not performant. Transferring that into something more scalable is either handed off to another team or the data scientists themselves don't have the expertise to productionalize that properly. In the model management phase, what I want to do is pick my best model, register it so I can use it, and a key step that's often skipped is I want to revalidate. So I want to use another set of data to confirm the performance of the model. Model management isn't just about registering my model for the first time. It's actually very much around how am I going to register my model and continue to tune my model in the future. Very often we're seeing that there's not a standardized way to compare the model from what was previously there to what's there now. And there's not a lot of focus on avoiding biases. So that's what we're doing with introducing the validation process. Very often there's not a standardized way to identify drift. So periodically evaluating to make sure that the performance is still there is not set up in a repeatable or automated manner. In the deployment phase, I'm getting the model ready to be used either in a real-time or batched inference. I'm deploying the API, as well as any prepared transforms. And finally, scheduling the inference if I'm in a batch inference scenario. In deployment, we find that a lot of teams are not using tools that are readily available to them, such as MLflow or Azure ML. With these tools, you can track both your code, your pickles, your experiments as you get them ready to go to production. So we've made it to production. Now we're in operations. Inferences are happening, predictions are being used, everything is great. But what we're going to start to see is a little bit of drift, or a lot of drift, depending on the scenario. With automated validation, you can revalidate your model that it's still performing, and you can actually go into retraining if you need to in order to ensure you've got the best model for your users as possible. At this time, we're going to be heavily focused as well on load management. Our API should be scalable, but we want to make sure that we're minimizing the cost as well as increasing the performance as we go. Often here, what happens is model drift is not proactively monitored. So your business users actually end up picking up on the drift. That's way too late. By automating this process, you can actually go in and retune your hyperparameters and retrain as needed, and even automate the deployment out. As well, the mismatch between computational resources and volumes causes either a performance degradation or a cost increase. So I hope this gives you a better idea on how to manage your MLOps lifecycle with these different phases. So why would you invest in an MLOps Accelerator? To provide that model drift identification at an early stage, optimizing your data scientists, which are often key resources that you have. Getting those ML models to production sooner is so key, and that cost reduction with more performant code. I'd like to thank you for taking the time to listen to this today. Please visit us at SDK Tek for more information.